It's my pleasure to introduce the very interesting speakers that we have this afternoon. This is a series of short presentations. It's a little slower than speed dating. I think you'll be able to get some good information. But we're going to try to keep on schedule as we move along today. If you haven't had a chance to visit some of the booths and talk with my knowledgeable colleagues outside, I hope you'll take a moment after the lectures. And if you sign our comment book, you'll be rewarded with chocolate. So we like to have incentives for things. I'd like to start with our first speaker today, Mark Ormsby. Mark has worked as a physicist at the National Archives for 23 years. When he started at NARA, he was concentrating on studying the condition of only 7 documents: the Declaration of Independence, 5 pages of the Constitution, and the Bill of Rights. Today, he's going to be talking about his work at the other end of the spectrum, studying how to preserve millions of documents housed in our storage rooms and buildings. Mark?
All right, thank you, and good afternoon. So I'll be talking about some work where we've been trying to look at our storage environments in our buildings around the country, focusing on first at College Park at Archives 2, and trying to find some ways where we can save some energy, but at the same time improve the conditions for the records. So the archives, as most of you know, we have all sorts of materials. They can degrade in all sorts of different ways. But in general, we can say that the chemical reactions that make things deteriorate need heat and moisture. And so one thing we can do to slow down those reactions to help make things last longer is to store them in rooms where it is cooler and drier. So this is an example, something I found on the web of someone who was someone advertising home remodeling services. And one thing that jumped out to me is this nice space up here, which is great use of the space. And it looked to me that like they have maybe DVDs or old VHS movies, probably family movies, that are stored up there. It's a great space. It's out of the way. Kids will be out of it. Pets won't get into it. But in terms of making your pictures, your old family movies and things last a long time, that's probably not a great space to store them. Because for one thing, it's going to be hotter up here at the ceiling than, say, maybe down in here in this cabinet. And also, if this window is on the south side of the house, that means it's going to be very hot on this wall and get hot up here. And that's going to make things age more quickly. If you stored them up here, then say maybe in here where it's going to be cooler. The other thing in addition to heat is those chemical reactions need moisture. And so we want to store things where it's not too wet and not too dry. If there's too much moisture, like if there's a leak in a roof or something, you run the risk of getting mold. But you can't make it too dry or things get brittle. If you have fragile papers, they can break. If it's too dry, the spine on a book might break. So we can't have things too dry. So there's a problem then. If you want to know where you should store your things to make them last the longest, well, you could put them in the basement where it would be nice and cool. The problem is that for most of us, the basement is kind of damp. So it's good in one terms, in terms of being cool, but it could get wet down there. On the other hand, you could put it up in the attic. In the attic, unless the roof leaks, it's probably going to be nice and dry up there, which is good, but it's also going to get very hot. So what's the better place to store things, in the basement or in the attic? So to get a handle on that, we need to think in terms of relative humidity, which gives us a measure of how moist the air is. And we can relate that to how fast things are going to deteriorate. And the archives has a long history of monitoring the humidity. This is a picture from 1942 showing a staff member in one of our stacks checking an instrument that measures the temperature and humidity. This is a hygrothermograph, which you may see in exhibits in different museums. It records the temperature and humidity on this paper graph. For our work that I'll be discussing today, we're using electronic data loggers, which have the advantage of recording the data and we can bring it into a computer and analyze it. And I'll be talking about that more in a minute. So the archives has standards for the humidity range, not too dry, not too wet, for where we store things, usually in the 30 to 50 degree range, depending, and with photographs, motion pictures, and electronic records, the humidity, we keep them at is lower because they have special issues with them. For paper, we have a wider range. And so in your home, if you're trying to keep things from getting too wet, you might use a portable dehumidifier, or maybe during the winter, you may be using a humidifier. For a big building like Archives 2, which I'm showing here, you have what's called an air handler system, which is a really complicated set of interacting pieces and components. It's a big unit. This is a ladder here just to show you how long this air handler unit is. And at Archives 2, we have over 30 of these big air handler units serving our storage areas. So, and what we did previously was pretty much year-round, we kept the humidity at about 45% in our areas that we're storing paper records. So this would be called flat line because we're keeping the humidity fairly constant, and we also keep the temperature constant pretty much year-round. This is from 2010 throughout the full year. You can compare that to, this is what the humidity looks like in a typical office space or in your home, where you just have air conditioning and you're not actually controlling the humidity. So the humidity gets dry during the winter, during a Washington summer, it gets nice and humid and then drops back down. So that would be in a typical office space, and this is the humidity constant throughout the year in one of our storage areas. And you can imagine that for these big rooms that we're storing records in, that consumes a lot of energy to keep the humidity constant. So the archives has done a lot of work. Our facilities group has made a lot of innovations to reduce our energy use. And in 7 years, they cut the energy use in the agency by 31%. And they've won national awards for that and continue to make great innovations and improve our sustainability. And you can read more about that online in our sustainability performance plan. So what we were doing was building on that work. And in 2011, we made a change where instead of keeping the humidity constant year-round, we allowed it to fluctuate anywhere between 30 and 50%. So we changed that in the fall, and the humidity came down. So we were allowing a wider range than we had been before in our areas holding paper records. We didn't apply that to electronic records or photographic materials. And this worked out much better than we expected. We thought had previous experience in the past where a storm had come through and maybe knocked out power for a few days. We knew that the humidity was going to change very slowly. And we didn't expect to see a big change over the course of the year. At least I didn't. But it worked out surprisingly well. You can see that through the fall and winter, the humidity came down. And this is what we expected in most of the stacks, that during the summer the humidity would rise back up. But still, we only got up to about 45%, which was what we were holding it constantly throughout the year before. That happened in a few stacks, a few of the 30 or so that we have, but most of them behaved like this, where it got dry during the winter, which you'd expect, but then it stayed surprisingly low throughout the summer. And you remember last year was very hot, maybe not as humid as some years because of the drought, but we were at much drier conditions in July and August than we thought possible. So what we can do is take this data that we've recorded in these electronic data loggers and see what the benefit of those new conditions were. And that's one of the benefits of having all this data recorded electronically is we can put them into a computer model that was developed by the Image Permanence Institute at the Rochester Institute of Technology. And based on that model, the paper records in our storage areas should last about 20% longer under these new conditions than they would have at the old conditions. So we've improved the lifetime of the records, and at the same time we've saved energy because during the winter we're not humidifying the air back up to 45%, so we're not using as much gas and water. And during the summer, since we started out nice and low in terms of humidity and in most of the areas, didn't come close to our 50% maximum, we didn't have to dehumidify the air as much during the summer. And dehumidification takes a tremendous amount of electricity. It's our biggest driver in terms of energy use. So what that turned out to, how the results came out in terms of energy, this is looking at electricity use over the past 4 years. You can see that it was roughly constant for these 3 years and then dropped significantly last year, which was the hottest year on record ever in DC. Natural gas use also came down compared to earlier years. And we also use less water in the past year. And in terms of the expense for those, compared to the previous years, or compared to 2011, our total utility use was about $650,000 lower than the year before. And part of that change, you see this drop here, part of that is because natural gas prices have dropped 40%. So this difference here is mainly due to change in natural gas prices. So that's why we're just comparing these 2 years. We still came out far ahead in terms of energy use. So the upshot of that experiment that we did was that the records will last about 20% longer, and at the same time we spent about $650,000 less on utilities. Now, our facilities group is continuing to do great innovative things to reduce our energy use, so part of that savings is from their work, part of it depends on variations in the weather, but we think a significant part of that savings came from this change in the humidity settings. And for future work, we've started this past year, we did a winter setback mode where we're going to a lower temperature during the winter months, going from about 68 down to about 65. We tried that out this year, and we're starting to analyze the results on that. And we're also in the process of developing energy savings performance contracts, which are a way of, if we have some equipment we need to replace, like Archives 2 is actually about 20 years old now. Some of that equipment is getting to the end of its lifetime, but we may not have money to buy a more efficient piece of equipment, especially with sequester going on. We don't have a lot of spare money. What these called ESPCs allow us to do is a company comes in, they develop proposals for ways to save energy, and they will pay the upfront cost of that equipment, and then they're paid off over the years by the savings in energy. So it's a way for the company to benefit and for us to benefit in terms of savings. We're in the process of doing one for Archives 2. The proposal's due at the end of the month, and they're also doing these at presidential libraries and museums and regional archives. And the Archives has done these ESPC programs in the past and have been very successful with them. So we're looking forward to saving more money and energy and hopefully improving the lifetime of the records through those programs. So I'll just finish by thanking my colleagues in the preservation programs, Gary Simmons, James Garvin, Nan Pham, and Mark Sprouse from the facilities department, who we've worked together to develop some of these programs and understand the implications, and also Ivan Austin, who's an engineer with LB&B, who implemented a lot of these results. And are we taking questions now or holding them? I'll take any questions that you may have.
An architect in designing not necessarily a stack space, but many parts of the building would consider like solar gain and the heat generated by coming through glass, and a specific part of a building as potentially like a positive thing, to reduce energy consumption, and therefore, are we trying to mitigate? We're not trying to mitigate this for the public spaces of the building. It's just the storage condition for the records themselves. Is that right?
Well, actually, we did an energy savings performance contract for Archives 2, I think around 2006, and that focused more on the administrative and public sides. So they did a lot of things with automatic light detection, replacing inefficient light bulbs and things. So they're looking at the whole picture. Part of that 31% reduction in energy use came from looking more at the public and administrative side. Now in this program, or this time through, we're looking more at the storage areas. And because of some new research in the preservation field and also some new technologies coming out in the heating and ventilation world, we think there's a lot of potential there to save a lot of energy and also keep the humidity lower than we thought we could affordably before. So it's both. At the presidential libraries, I think they'll be looking at both aspects of that too. Okay, any other questions? Yes.
Hi. Like, how does NARA compare with other museums, and do you do comparisons with other museums or different archives as far as energy savings and things like that?
We're leading the field. Actually, we're very involved in working with the Image Permanence Institute, using their tools. There's a lot of people throughout the world looking at energy efficiency and sustainability. It's difficult to compare an archives with a museum. If you get 1 million visitors a year in your exhibit space versus here we're in research rooms predominantly. So I haven't seen numbers comparing that. What we can do is look at our different facilities around the country and look at our energy use per square foot. Comparing regional archives, presidential libraries, Archives 2, Archives 1. With 70-some facilities around the country, we can make comparisons to look at, well, why are things so much more expensive here than here? Or what could we change to make things more efficient? So I don't know if that answered your question, but.
One quick question. Is
Yes.
a box essentially a microclimate? In other words, you can alter the environment surrounding a box, but does that really affect what happens to the paper that's tightly packed inside a box? But there's not a lot of air. So,
Right.
And what is the, do the data loggers themselves, are they inside boxes or are they on shelves, or is there any consideration in data collection given to the difference of what's happening in the box versus what's in the air?
Right. And the model that I mentioned takes that into account. And that's the advantage of that this model that we didn't have, say, 20 years ago, we've known for a long time that cooler and drier is better, but how do you take account of these fluctuations? And so this model looks at the average of the temperature over 24 hours, and it looks at the average of the humidity over 30 days. So the humidity response is much slower than the temperature, but that does give us kind of an average picture of how things change inside a box or in a bunch of records grouped together on a shelf. So it's an average picture, but pretty realistic for the impact of that. Okay? All right, thank you.